Hey there. This video is a demo for a React library called React Query. React Query has gained a ton of popularity over the last year or so, and even more so in the last few months. So I just wanted to explore some of the high-level APIs that this library has to offer. So what is React Query and what problems does it solve? The documentation states that React Query is a data fetching library for React that makes fetching, caching, synchronizing, and updating server state in your React applications a breeze. So React doesn't really come with an out-of-the-box solution for data fetching or managing that state. So React Query is a third-party library to try and abstract away some of that logic for you. Before we begin, I want to just give a quick shout out to the Net Ninja. I sort of like ripped a lot of the code for the demo app from this guy. He has a playlist for React Query, so just wanted to give that credit. So first we'll explore the app. So the app is just like a simple Star Wars info app. If you click planets, it gives you the planets. If you click people, it loads and gives you the people. There is like a quick loading state. This API responds pretty quickly, so it just sort of blinks. But you get planets back. You get like 10 or so planets back with a little bit of information on each card, and then people, the same thing. So we'll start by just exploring like how someone would solve this, just using like vanilla React, no libraries. So if we look at if we just kind of explore the code real quick, we have our app level, which manages the page and setting the page based on what the user clicks. This component isn't going to change much. But if we look at planets, for example, we have these different state setters for loading, data, and error, and then we have a function here, an async function, to fire off the request, set those different states, and eventually render, based on what state it is, eventually render the planets, or a loading state, or an error state. And then the same thing for people. It's pretty much the exact same code, just a different endpoint. And then the single planet component is just like an actual, like just one single planet, since the planets component maps out a planet. And then the same thing for people, or the same thing for person. We're not going to be touching person or planet at all. We're mostly going to be focused on the planets and the people, which is where the data fetching happens, that's what we're interested in. So we can see here like how much code this is, like how much business logic is in our code here, and this can seem a little bit verbose, like all of these states right here, and then we're not even including like other states that you would possibly need, like retrying slash refetching, maybe canceling a request, and that can get quickly out of hand. And this is only for one request. If we had multiple requests in this component, this like these would double, everything would double, and then maybe you would end up like wrapping this in like a use reducer, and you would have to start abstracting that out, and then you would start to build something that starts to go in the direction of something like React Query, where you are building like wrappers or abstractions, sort of like what React Query sets out to solve. And then the problem with that is that the burden to test and document those abstractions that you've home baked are now on you, rather than outsourcing that out to the community. One of the things I want to point out before we see how React Query can help simplify our problems is, you'll notice that every time I click planets or people, we get a loading state. We just loaded that, and we go away, and then we go back, and it has to load again. And that's a network request for every single time we change. And that can get kind of expensive. Maybe not in this example, but that can really add up if we have large data sets. And also, it's just sort of a jarring experience, like what, like just that loading, that blinking of that loading. It just, if someone's hopping back and forth, it's not a great experience. And this is where React Query really comes in with caching. And with React Query, you get caching out of the box. You don't even have to think about it. It just works. And I'll show you that. So we'll go here. I'll switch branches. So I left pandas.js with the vanilla use state stuff, and I refactored people.js to use query. So just to run through it real quick, we got rid of all of the use state. We're not even using that anymore. Instead, we imported use query, and that's all now just this hook. This hook accepts a unique key, and then it accepts an async function. And this is our async function. And that async function, you do your asynchronous operation there. And what's great about React Query is that it's not really opinionated to any sort of fetching library. So you can use fetch, you can use Axios, you can use any number of fetching library that you want. So that's really cool. So I used Axios here since I'm really familiar with Axios. And we're using Axios to hit the people endpoint, and use query gives us back a data property and a status property. And using that, we can then conditionally render what we need to render. So this is the really cool part, is if we go back to the site and we refresh it, if we go to people, which is the one using use query, we get the loading state, which is what we expect. This is the first time it loads. We go back to planets, we get the loading state because that's using the use state pattern. If we go back to people, it's instant. If we go back to planets, it has to load. People is cached, planets is not. So we get just caching out of the box for free. I mean, this is literally just like 1, 2, 3, 4, 5 lines of code where we didn't even have to think about that. So that's really cool. The unique key that you provide here, that is what's used internally in React Query, and that's used for determining refetching, caching, and deduping related queries. So just wanted to cover that. Another thing that's interesting is that React Query has a retry functionality built in, and by default, if a query fails or a network request fails, it'll automatically retry it 3 times, and it'll show you the loading state. The status will stay as loading, so it's sort of seamless to the user, where they're not even aware that a network request is failing. Maybe it's failing because the user's internet is spotty, or maybe it's failing for a host of reasons, but React Query is going to just seamlessly retry that in the background. And I'll show you that real quick here. So if I come to people and I just sort of like mangle the API response, and we open the network tab and we go to people, it fails, and then we get an error response. And so during that time, it was just showing the loading. So if it would have been successful on, say, the 3rd try, it would have just showed the data, and the user would have never even known that any of the requests failed. So I thought that was really cool. And that is configurable, of course. It's by default set to 3 retries. You can set it to 0. You can set it to however many you want. It's just like a config property that you can pass in. So that just covers like some of the basics of, or just like the very basic API of React Query, which is the use query hook. Another thing I want to show you is the React Query dev tools. Now this really blew my mind. So adding the React Query dev tools was super easy. You just bring in this this library, React Query DevTools, which exposes a component, and then you just throw that adjacent to your app. And this is built in to not render if the app is in development mode. That's just done in the background, so you don't have to worry about this ever showing in production. And what this does is that it just gives you this little button down here, and you click that, and this gives you like a whole dashboard of like what's going on with your app. So we can see each of our keys here. It shows us a status of fresh. It shows us a status of fetching, stale. We can refetch here. We can look at all the information about our request. We can look at the data that's returned. So I thought this was really cool. So if we again go to, like, let's say we go to this planets, and we change this to some endpoint that doesn't exist, we can actually watch the failure count go up to 4. I don't know if you saw that. 2, 3, 4, and then it goes to error. So this dashboard I can see being really helpful. Another thing to show you is, so I'll show you some of the configurations for useQuery. These are all of the things you can pass in. It's very configurable, very flexible. There's a few that I wanted to show you. There's one called cache time. So we'll go ahead and we'll pass in cache time, and this is how long useQuery caches your data, and by default it's 300,000 milliseconds, which is 5 minutes. So instead I'll change this to 5 seconds. And if we go back to the app and we go back to planets and then we go back to people, you'll see here after 5 seconds planet will just disappear. And so if we go back to planets now, it has to load. So you can mess with the cache time. Another one is stale time. So what stale time does is you're essentially telling React Query, let's go look at the API. The time in milliseconds after data is considered stale. So we're saying for 5 seconds this data is considered fresh. So you can see that here. If we go to planets, it's labeled fresh right here in green, and after 5 seconds it'll go as stale. One of the ways we can demo this is that if we hit people, and so React Query has a refetch on window focus. So the query will refetch when the window is focused. So if we come back, if we look at people and I click outside of here and then click into the window, you see how it refreshes. So I'll click out again and click in. But since planets is set to a stale time of 5 seconds, if I click within the window within 5 seconds, it doesn't actually, it is still fresh. So we'll see that here. You see it's fresh, I click out the window, I click back in, nothing happens. So that's just like another thing to mess with. Another one is retry. So I said this earlier, you can set this to like 10, it'll retry 10 times. And then lastly, I wanted to show you enabled. So enabled is set to true by default, and all this means is that when this component loads, when this component mounts, the use query will fire off immediately, and it'll do the fetch will happen immediately, just like implicitly as it mounts. But you may not want this to happen because maybe this should be attached to some kind of button, and the user will fire this off by submitting a button or something. So you'll change enable to false, and then there's another property called refetch. And so I'll just make like a button here. I'll call this get planets. We'll add that on click to fire off refetch. So then if we close the dashboard, so now when planets loads, nothing happens until we hit this button. So it's more explicit, and then people is still implicit. So there's another thing I like to show you called query variables. So I'll go ahead and switch branches. So query variables are if you want to pass in arguments into your async operation. So earlier we were doing just like a hard-coded people endpoint. But what if we wanted to like pass in some kind of like dynamic page number, or just any kind of query param, or just a different header on Axios? Who knows? Like, how would we get that from this component state into here, into our operation? And the way that you do that is use query. The first argument, the query key, can accept an array, and the array will be the first item in the array will always be the key of the query, and then every item after that will be an argument that gets passed to the operation, the async operation. So what we're doing here is we are passing in a page number, because the Star Wars API accepts a page number query param. And so we'll let the user choose the page number based on these buttons I threw in here. So we pass in the page number state, which is changed based on the button. So the key and the page num get passed into the fetch planets function, and then we just pass in that page num here. So if we go back to the browser, we can swap between the pages, and you'll notice now that each page is loaded, it's just like an insta load now, because it's all cached. And now everything's cached. So everything is just super snappy. So that covers all the basics of React Query. There's one more. There's one more that I wanted to show you. This is another big API. This is use mutation, and this is used for post. I don't have a demo for this, but this is used for server side effects. And the reason you would want to use mutation is because there's APIs built into React Query to handle mutations, and one of the really cool ones is optimistic updates. So on mutate, you can have some operation happen, and so optimistic updates is sort of like chat apps are famous for this, where you send a message and the UI updates immediately, even though that maybe that message is going to eventually fail. But 9 times out of 10, it probably won't. And React Query handles this really seamlessly, where if it does fail, then you can handle the failure. Otherwise, to the user, it almost feels like they're using a synchronous app, even though there's a lot of async operations happening in the background. So that covers all of the code demo. Back to the README. So what are the trade-offs to rolling your own? So the first thing we explored, which is like using just use state or use reducer, and like using something like React Query is like you're gonna get like the typical trade-offs of using a library, which of course is like less flexibility, and just something new to learn, whether it's new devs, and this comes with really any library. There's no like super obvious issues with that I've found yet with React Query, and I hope this list grows, because obviously there's going to be more trade-offs than just this, but so far it seems really robust, and it's not like React has something built in that this needs to challenge. React's more of just like you go and build your own. And if a community has built their own and it's gained a lot of popularity, that is something to explore. But certainly have to be careful on the whole shiny new toy. So how does this hold up to other alternatives? So this table compares React Query to SWR, which is made by Vercel or Zeit, and Apollo. And right off the bat, you'll see that React Query also supports GraphQL. Apollo is like super popular, but you can really only use it if you are using GraphQL. So that's kind of a bummer. But React Query, it's, if your team ever switches from a REST or a promise pattern to GraphQL, you're pretty much good to go. And there's like this table just kind of like just list out a lot of comparisons, but at first glance, it really seems like React Query holds up. And just some other features to list. React Query ships with TypeScript. It has pagination pagination support. There's like a use pagination hook that you can use. There's, like I said, the GraphQL support out the box, caching out the box. The dev tools are really cool. The community support is really growing. Like I said, it's only a year old, but it's already really popular. Prefetching, like a sort of, if you can like deduce what the user is going to do, you can do some prefetching to have that data ready, so it feels even more synchronous. Canceling request, it's really seamless to add in canceling request, so you're not if a user changes pages, you're not just like firing off requests for no reason. Optimistic updates, and then it has support for React suspense and a bunch more that you can check out on their docs. That's pretty much it. I'd invite you to check out some of the documentation and maybe just explore building like a toy app. Yeah, so that's the demo of React Query.